This is another one of my ROV underwater drone videos I'm working on. And this is my ROV, my underwater drone. And little by little, I'm getting it together. Now what I need to do now is I need to test to see if these DC motors, I got 4 motors on here. So they have, they're DC motors. I believe they're 7.2 volts as their operating voltage. And they have little boat props on them. These are underwater motors for underwater applications. So they're brushed DC motors, and the reason for brushed is that I will be able to run them with direct current DC voltage, and so that'll enable me to not have to have a battery on here. If I was using brushless, I'd have to have a speed controller for the motors. And I do have speed controllers. They're DC speed controllers. But I won't have to have relays. I won't have to, on the unit, I won't have to have relays on this unit. I won't have to have a battery on this unit. None of that. Everything's going to be out of the water. So it'll be either in my control box, which will be the DC voltage controllers to run these motors either forward, reverse, and also control the speed from 0 to as fast as I can make them go. So, but what I need to do now is that the cable that's going to attach to this, it's going to run these motors, is going to be 150 feet long. This will eventually have the depth capability of 150 feet underwater. And hopefully, we'll see. I don't know if these motors can take that depth. I know the lights that I put on here can't. They're only rated for 33 feet, so I'll have to change these lights out to something else, but it's doable. And the camera that I'm going to use to drive this is a fishing camera, and it has a 150-foot cable, so it can go 150 feet down underwater. I'm going to have my GoPro camera on here. Right now I don't have an underwater housing for it, so I can't go that deep. Mainly the reason I'm building this is to inspect the bottom of my boat, so that it only has to go maybe 6 feet down at the most, 6 to 8. And so that's mainly what I'm using it for, but it would be nice to be able to go 150 feet down in case I drop something overboard. Also, I can go out a long distance away from the control area. So what I'm going to do now is I'm going to test one of these motors through 150 feet of this cable. And I decided to try using an Ethernet cable, and it's a Cat 6A type cable. So it has 8 conductors in it, and that's what I need because each motor has 2 wires. So I'll need 2 wires for each motor. So there's 8 wires in here in this cable. So I'm going to have to cut the ends off this cable, and I'm going to have to strip the ends, and then I'm going to take two of the wires, they're all color coded, and attach 2 to the motor and attach 2 to this DC voltage power supply, which I can control and adjust the voltage and the amperage. So I'll slowly up the voltage and the amperage and see what I can do. The amperage is no big deal. I can turn the amperage all the way up. That shouldn't be a problem. And that's what I'm going to want to do. I'm not sure how high the amperage goes on this, but it definitely does not go as high as my house lithium iron phosphate battery bank that I built. That's in here. I have a 12-volt battery system that I put together myself. And it's over 10,000 watt hours of storage. And it can produce 1,800 amps continuously, instantaneously. So there'll be plenty of amperage, but the motors are only going to draw the amperage that they need. So right now I'm going to connect this 150-foot cable and see if I can make this motor spin at 150 feet, because the thing about low voltage 12-volt systems, and that's why a lot of boats are like 48 volts, some are 32, 48, some of them go up to higher than that. up into the 70s or even higher. But 12 volt is real common on a boat, and most of the items that you get for a boat are designed for 12 volt systems. So I'm talking like light bulbs and things like that. I mean, now you use LED lighting, and a lot of refrigeration units are set and designed for 12 volts. So I decided to go with 12 volt system. My battery bank I built for this boat, I can rearrange it to any voltage I want. But I decided just to go ahead and go with 12 volts because the boat is set up for 12 volts, and that's the reason. The only problem with 12 volts, the lower voltage, is line loss. You get line loss. So theoretically, if you have 12 volts and you run it through 100 feet of cable, you're going to lose half your power. So that's what I'm going to test for here to see if this is going to work. So we'll see. So that's what I'm going to do now. So I just got to pull this cable out. They come in different colors. I just happen to get white. So I'm actually going to put 2 of these cables together because it has 8 conductors. I have 4 motors, and this will run the motors, but I do want to be able to add other implements to this. So, for instance, a claw, a manipulator, so I can, it's like a hand that I can control that's going to go on the front of this, so I can go ahead and pick things up, you know, if I drop something on the bottom, or if I happen to get into treasure hunting, which would be kind of fun. And I'm also planning on maybe putting a metal detector on here, and I'm also planning to build an implement for cleaning the bottom of my boat, which that'll be interesting to see if I can make that work. But for right now, I'm just going to cut these ends off and get 2 of the conductors and connect 2 to the motor and 2 to this power supply. Start cranking up this power supply and see what happens. See if the motor spins and at what voltage. So I'm thinking these are rated, and I think they can take 12 volts. I'm pretty sure they can, but they're actually rated for 7.2 volts, which actually might be a good thing. So we'll see because of the line loss. We'll see what happens. So first thing I got to do is just cut the ends off. I hate to do this because they got these cool little connectors on them. And so I'm just going to cut the wire because I don't need these connectors. They're not waterproof. I did get waterproof housings for these, but they were way too big. So I had to go with something different because these cables are going to connect to here, and eventually I want this cable to be able to, I want to be able to remove the cable from this unit for storage. So I'm just going to go ahead and cut it off. Let's cut it off right there. And these cutters aren't good. I should have got my other ones. Good enough. Cut the other end. And then I strip them. So I got these really cool wire strippers. I don't know if it's going to strip this cable. Let's see what happens. I don't know. Yep, I did. There you go. And see all these nice different colored wires in here. So now I got to do the other side. Yeah, it looks like I'm okay. I didn't cut through the wires, so that's good. Now, these wires are awful small, so this may not work. I may have to go with something else. I may actually eventually, if none of this works, I may have to put relays on the unit, which I really do not want to do. I've seen people make these do DIY underwater drones using this type of cable, but I'm not sure how long their cables were. One looked like it could have been maybe 100 feet, but this is 150 feet, so we'll see. It's going to be interesting to see if this works. If it works, I'm going to be really happy. I really like these wire strippers. They're really handy to have. You can strip wires really fast. There it goes. Okay, let's see if I damaged them at all. Nope. Okay, that was good. All right, now I just got to pick out 2 colors. So I got white. Okay, I got to be real careful here. So they're twisted pairs. They're 4 twisted pairs. One is, each one of them has a white wire, and then they have a different color wire. So just got to make sure I don't unwind them and lose track. So I guess the motor is blue in color, And there's a blue and white one, so what the heck, I'm gonna go ahead and use the blue and white one. So I'm just gonna untwist it, and now I just need to, so you can see here, I think, hopefully you can see that. So there's 4 twisted pairs, and that's 8 wires total. So, oh, okay, so the white wires are also color-coded. So the white wires has a little blue stripe around it. So that's good. That way you can't get them confused. So now I'll see if this will cut these little tiny wires and strip them for me. Yep. And you can see how good these work. I mean, all you got to do is this. It's no messing around. Boom, stripped. That quick, that easy. And perfect without damaging any wire. These wires are really small. I don't know if this is going to work. Hopefully, I'm thinking it should, but we'll see. Normally to run 12 volts a long distance, like 150 feet, you'd need huge, big copper wires, and we'll see if this is going to work. Okay, now I got a red wire and a black wire on the motor. So the black wire I'm going to hook to the white wire on this cable. And that's negative. So black and white will go together. And I'm just going to twist them together. Don't need to connect them, just this is a test. So twist them good, so they're good and tight and connected well. Now I got to just make sure they don't touch each other, because that would be not good. I'm going to connect the blue and red one together. And twist them. Okay, now the motor is connected. Make sure they don't touch. I'm going to kind of bend them away from each other. Okay, now this other side, I'm going to connect the black negative to the white one, and I got alligator clips for that, so this can make it nice and easy. And again, I got to be real careful these don't touch. And now the red one and the blue one together. Okay, now moment of truth. Let's make sure these don't touch. They always want to kind of get close to each other when I'm doing stuff like this. Okay, now I'm going to crank up the voltage and the amperage. So I'm going to crank the amperage up first and just kind of get it set. I'm not going to go real high on it, but I'm going to crank it up. Let's see, that's full blast, but I think I'll back it off a little bit. I'm going to crank the voltage up since I got to hold this motor because it's going to start spinning. Hopefully it'll start spinning. So now I'm going to start cranking up the voltage. And we'll see what happens. This is the test. Is it going to spin? There it goes. Wow, look at that. 7.3 volts and it's spinning really good. This is going to work. Fantastic. Look at that. I'm not going to go any higher than that. So I'm at 7.3 volts and I'm drawing 0.13 amps. And at 7.3 volts. So let me back it down. Okay, now it's slowing down like a speed controller. See that? It's going slower and slower and slower. Now if I go to the fine adjustment, I can really adjust it. Let's see, that's faster, that's slower, and look at that. So hopefully you can see that and spinning. So the speed controllers that I have will do the same thing. And so the system's set up for 12 volts. I might have to cut the voltage back. I'll have to be careful with those speed controllers and see, because I get a double check. Now I'm pretty sure these were rated. They're designed to run at 7.2 volts, but when I bought them, it said that they were rated, or they were designed for 12 volts. But I've heard some people had hooked these up to a 12 volt system and burned the motor up really quick. So I'm just gonna have to be really careful with that and figure out what I'm gonna have to do if I need to regulate the voltage, or just make sure it doesn't go over 7.2. But I am running this motor now, and let me turn it up full blast on the voltage again. Well, I'm not going to go full blast. I want to go up to 12, but I'm going to go up to 7 volts, 7.2. Cut this back. Okay, so they're rated at 7.2. And that's 7.2 volts right there. So that's, it's running plenty fast, but there you go. I'm running 7.2 volts here on the power supply, and it's running this motor. Looks like that's going to be plenty fast enough for what I need. I might be able to go up faster. Like I said, it may be able to go up to 12 volts, and you know, maybe the reason people had a problem with the motors burning out so fast was the ambient temperature. This is going to be in the water, so it's going to be, these motors are going to be water cooled. So I'm able to go higher than that. But there you go. This motor, this power supply at 7.2 volts, running through 150 feet of cable. This motor is running no problem. So this is going to work. This is really good news for me. It ain't going to be a problem at all. So yeah, this is awesome. So this test was a success. Oh, makes a nice little face fan too. Whoa, 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 I'm touching wires here. Careful, Tom. Okay, I just shorted it out here for a second, but it's okay. Kind of stuttered. It's just, I touched wires that I shouldn't have touched. I touched the positive to the negative. That's not good. That's a big no-no. But let me look at the voltage again. And I'm going to cut the amperage back now and see what happens. So 7.2 volts. Let me get it exactly. Okay, let's see what happens when I cut the amperage back. Okay, yeah, so you cut the amperage back, it's going to shut down because there's no amps. But there we go. Now see what happens. I'm going to crank the amperage all the way up. Shouldn't matter. Because the motor's only going to draw what it needs. So there you go. It's full amperage, 7.2 volts, 0.13 amps, and it's 0.935 watts. So that's awesome. This is really good news for me. So this is definitely going to work. I'm getting real excited now. Now, next I'm going to go ahead and go back working on my control box. I'm going to go ahead and get some of that stuff put in. So I'm going to have to just kind of clear this area up and get ready to do a little more work on that. This has turned out really cool. This is definitely going to work. As long as my ROV don't sink, because I keep adding more weight to it and it only has so much buoyancy. I may have to add more buoyancy, and I hope that's not the case. These two lights, they're for video, so they don't strobe. And I tested them, so they work good. They should be plenty bright. I think they're 900 lumens. So they, at 1 meter, if I'm not mistaken. So they're going to be plenty bright, and I can adjust the brightness. There's 4 different brightnesses that I can adjust these to. So the lights are going to work good, and I can turn them a little bit so I can see, adjust them a little bit. And the reason for that, the reason I want them to adjust is to when you do underwater photography, there's little air bubbles, and if you have the light, if the camera lens is here and the lights are here close to the camera lens, you see a lot of the little bubbles in the water. So it kind of is distracting. And if you get the lights farther out and angle them in, then you're lighting the bubbles from the side, not from the front, so they don't show up as much in the water. So that's why I made them adjustable. I may have to put them out farther if I have a problem with that. Hopefully I won't. Or just have to live with the bubbles, which will probably be okay. So anyway, so I have, again, 4 motors here, and 2 on the top and 2 in the back. So the 2 in the back, and they're just sitting in here right now. I don't have them attached. The 2 in the back, they're for making the ROV go forward. or reverse, and then I can control the speed of each one of these motors separately, so I can make the ROV turn. And if I put one motor in forward and the other forward in reverse, I can turn real sharp right on a dime. If I can also, because of the way I can control this, can make big sweeping turns. And then the two motors here in the middle on top, this middle one here is to make the ROV go up. Actually, it pushes it down. And these are buoyancy tubes to bring it'll float back to the surface without the motor running. And that's what you want. So you want it to be slightly buoyant, so if something fails, it can surface on its own. But you don't want it too buoyant, because then you're going to have to run a lot of power and run this motor a lot to push it down. And the farther down you go underwater, the more buoyant things become. So that's what this motor in the middle is for. This back motor is so I can adjust the pitch, so I can pitch it down like an airplane flying towards the ground. And that way the cameras, there's going to be two cameras right here in front. One's for driving the ROV, and then the other one's going to be for my GoPro, so I can get 4K video underwater, so I can get real high quality video. The fishing camera I'm going to use to drive this is not 4K, and it's actually CCTV, closed circuit TV technology. So it's color, but it's not the best quality. And so this back motor will allow me to pitch down so I can see the seabed better with the cameras, or I can pitch up, drive level or pitch up as well. And here's one of my motors. Pitch up so I can see towards the surface. So with these four motors, I should be able to control this in any direction I want to. The only thing it won't do is it won't be like an airplane that banks like this when it makes a turn. There's no need for that, because it's going to make the cameras are now, the bottom's going to look crooked, and with the cameras. So there's really no need for that. And so it'll float level, always float level like this, which is good, because then it'll keep the cameras level. So that's what you want. So I should be able to get this to go in any direction, any depth down to 150 feet, and pitch it down or pitch it up. And I have the speed controllers for these two motors are dialed. So I have dials. I also have remote controls for these two. And because the dials are stepped, so they go click, 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 click when I turn them, I'm hoping that I can be able to set the depth and keep it at that depth. And then I don't have to touch the knob, it'll stay there. I'm hoping that's going to work. This is going to be real important, especially for like cleaning the bottom of my boat, because I'm going to start at the surface and go around cleaning. I'm going to have a scraper on the side of the ROV. There'll be a scraper I'm going to build for scraping the bottom of my boat. And then I need to go, and it's only going to be maybe a foot wide. So then I'm going to need to drop this down a foot. So hopefully I'll be able to click it a couple clicks and keep it at a lower depth. So it'll be like a foot now underwater, and then after it goes around the boat, cleans it, then a couple clicks, maybe another foot, till I go down. Like I said, the boat's 6 feet deep. But because the hull curves like that, there'll be a lot of variation there that I have to continue down to get down. Now the scraper, because the boat curves, I haven't figured that out. I don't have any way to make this do this. So what's going to happen is that the scraper itself is going to have a pivot, so it can pivot. So this will stay level, and the scraper will like pivot like this. So when I start getting under the under part of the boat, this will stay level, but it'll be able to scrape. It'll be able to scrape the bottom like that. And then once it gets down to the keel, it'll be more vertical again. So then it'll straighten out. But the scraper's going to have to pivot. I haven't figured all that out yet, but it's going to be awesome if I can make that work. That'll be really cool. If you found this video to be entertaining or helpful, please like and subscribe.